Okay, so exponential and log equations. To solve an exponential equation, both sides must have the same root, and they must be expressed with the same base. So it shows an example with letters here, and we're going to do an example with numbers down here. So if it has the same base here, so b is the same as b, then you can set the exponents equal and solve for whatever the exponents are. So in the first example, we're doing exactly that. We have 3 raised to the x power. We're trying to figure out what that x power is. In order to compare it to the other side, we need this to have the same base. So if we were to break up 9, it would be 3 and 3. So that would be 3 raised to the second power. And then we can set it equal to 3 raised to the x power. And then since we have the same base, x equals 2. Okay, and then the next problem, of course, they gave us a fraction right off the bat. Okay, so fractions are there, it means negative exponent. So fraction means there's a negative exponent. Okay, so we're looking for a base of 3. We'll get to the negative exponent in a second. We're looking for a base of 3. If I break up 27, there are 3 3's. So 1 over 27 would be 1 over 3 to the third power. And then from here, this means negative exponent, so 3 to the negative third equals 3 to the x power. And then x equals negative 3. Next one. This right here, we have 2, and then 16, if we were to break that up, we get 4 2's. So 16 is 2 to the 4th power, which is good because we need a base of 2, but how do we combine the 4 with this here? So what we do, it would look like this, 16, 4 times x minus 1. I wrote the wrong thing. Thanks. 2. That's what I meant. Okay, then now that we have the same base of 2, not 16, we can set this equal to this and solve for x. So 3x plus 1 equals, and then distribute your 4x minus 4, and then solve for x. Okay, now we're bringing in the logs. Log is, based on Google, is a mathematical expression used to answer the question, how many times must one base number be multiplied by itself to get some other particular number? So it has to do with exponents. This right here, logarithm rule, this equals this. Today, we're going to focus on the setup. We will bring in the calculator function. I don't know if you've noticed, but there is a log button on your calculator, and we'll bring that in soon. But for right now, we're just focused on the setup. And yeah, so one of the big things that we're going to use throughout this lesson is, and write this down, maybe in colored or highlighted, base is the base. Base is the base of the log, but we'll just keep it as base is the base, and exponent at the end. We should make a song or something because we're going to be repeating this a lot. So in the log, this is the base number right here and right here. So when we refer to base of the log, that's what we're referring to. So this is a logarithmic function. Okay, so here's the base of the exponent. Base is the base. So we're going to do log 5, base 5. And exponent goes at the end, so we're not quite there yet. So we say log 5, 25 equals 2. Now we follow that same thing. Base is the base, exponent at the end. So this is our base. So log 16 exponent at the end.
Why did you put the 1/8 next to log 16?
I don't know, it's not part of the chant. That's where it goes. Base is the base, exponent at the end, and then the other number goes right here. Okay, then number 6, again, base is the base. Exponent at the end. So something to also note is log of 10 is a common logarithm. With log of 10, they usually don't write the 10. They'll just write log of 0.01 equals -2. If they don't have a base noted, then the base is 10. Write each equation in exponential form. So now we're working backwards. And remember, base is the base, exponent at the end. So base is the base, exponent at the end equals 16. Which, 2 to the 4th power, yes, that would equal 16. Okay, base is the base. It doesn't have a base there, so that means the base is 10. So base is the base, exponents at the end is 100. Which,
Why is it 10 squared?
base is the base. So since it didn't have a base there, it's 10. Exponent at the end. And then equals this number.
But I thought exponent is supposed to equal the exponent. Because like for the last one,
So we're working backwards now.
oh, okay.
Sorry. Okay. Just base is the base, exponent at the end. Then 9, base is the base. So base here. Exponents at the end. Okay, this statement right here actually has to do with the next page. It should just be like on the next page, but if you have the same log with the same base right here, then you can set x equal to y and solve for whatever you're trying to solve for. So that's going to come up on the next page. Okay, so right now let's flip to the next page. And it says evaluate. Evaluate what? Well, equals x. Base is the base, exponent at the end. So 3 to the x power equals 81. Now to solve it, we're going to solve this like we did in the beginning, where we get the same base, and then we can set the x is equal. So 81 can be broken up. There's 4 3's there. So 3 to the 4th power equals 3 to the x power. And then x equals 4. Okay. Then over here, doesn't say what the base is, so that means the base is 10. Put it equal to x. Base is the base, exponent at the end, so it's 10 to the x power equals 1,000.
Will we mostly see it this way, or will we have to You know where it was like flipped, so you have to do that on this one.
I don't know if there's one way that you'll see more than the other. I don't know. Then from here, we're trying to figure out what the exponent is. Some of you might be able to figure it out on your own, but if we get to the same base, then we can set the exponents equal. So if we break up 1,000, that'd be 10 times 100, and 10 times 10. We got 3 tens, so that'd be 10 to the third power equals 10 to the x. We get x equals 3. Somebody in my last class asked why we didn't break this up more, because we can break up the tens, and it's because we were looking for base 10, so we're good. Okay, next. Okay, solve each equation. Okay, so now we have more logs. What we're going to do here, it doesn't say what the base is, so that means the base is 10. 10 raised to the x power, base of the base, exponent at the end equals 0.1. We have to figure out what the exponent is. We're trying to get the same base on both sides, so that way we can just set the x is equal. But they give us this. What the heck? But that's as a fraction. 1/10 would be 1/10. And 1/10 is 10 to the negative 1 power. So x equals negative 1.
Can't you not have a negative?
Oh, so you read that? That has to do with the 17 and 18.
Oh, okay.
Yeah. 13. Log of base 1/2, 256 equals x. So base is the base, raised to the x power equals 256. Okay. Okay, so this 1/2, the 1/10 was 10 to the negative 1. So 1/2 would be 2 to the negative 1. 2 to the negative 1, you can do negative 1 times x, so you get 2, negative 1x up here. Equals 256. If you're to break that up, it's 8 2's. So it's 2 to the 8th power. And then negative x equals 8. So x equals negative 8. 14. Base is the base, exponent at the end, so we have 27 raised to the x power equals 1/3. One third, 3 to the negative 1 over here. And then 27, I'm trying to get to a base 3. Yeah. 3 to the third, so it'd be 3 to 3x. And then you can set your exponents equal. Probably should zoom out so you can see that one still. Okay, so 15, base of the base, exponent at the end, so 9 raised to 3/2 power equals x. Say what? This is actually bringing in what we did yesterday. Remember yesterday it was power over root. So therefore it would be 9 to the 3rd power, square root, equals x. 9 cubed is 729. Square root of that, x equals 27. Okay. Okay, so 16, same thing, base of the base, exponent at the end, equals 27. Power over root, x cubed, square root, equals 27. Then from here, we're going to try to get x by itself. First by squaring both sides. Then take the cubed root of both sides. So honestly, these last two are probably easier and will feel less new than all the other ones. 17 and 18, we have the same log with the same base, so therefore we can set this equal to this. So x squared minus 15 equals 2x. Then we will factor this out. Here's where like the whole year's worth of work comes together. Okay, so we got these two values, but it says plug the values back in to make sure it doesn't take a log of a negative, which isn't allowed. So what we do, or what that means, is we're going to plug in 5 to both of these. So it would be 5 squared minus 15 and 2 times 5. And then we plug in negative 3. Negative 3 squared minus 15 and 2 times negative 3. Here I get 10 and 10. And this comes out to negative 6 and negative 6. The positive 10 is fine, that works. Can't have a negative here, so we have to throw this answer out. And our answer is just x equals 5. Okay, same process for this. We have the log with the same base, so we can set these equal. Positive, positive. This came out to a negative. So this cannot be a solution, and our answer is x equals 5. And that's that. Getting smart.